It is common for artists to create summary viewpoints or use moving shots and demo reels to showcase their 3D models. However, it can be tedious to manually generate such viewpoints and 3D camera motion paths using traditional modeling applications. Previous work has proposed solutions, but they are mostly designed for the viewer, and it is unclear how such summaries could be authored. In this paper, we assist the view authoring process of the modeler by taking their own editing history into account. Our first observation is that artists tend to use short, localized strokes and usually focus on one feature and sculpt it in detail. Another observation is oscillations in the camera movement path. Due to the lack of disparity information, artists tend to sculpt at one viewpoint, move to another side view for inspection, and then come back to the original view for sculpting. Here is another example of such a movement pattern. Based on these observations, we design a back-end viewpoint selection algorithm and propose a history-assisted viewpoint authoring system for 3D models. Our system is embedded into MeshMixer, a 3D sculpting tool. At the top is the main window for inspecting the 3D model. The bottom left window is the authoring panel. Here, all authored information is shown in the context of the 3D model. The bottom right is the navigation panel. A version slider can be used to navigate between different 3D model versions. The user can interact with both the authoring panel and navigation panel to access previously authored views. Now, we walk through the view authoring session and introduce features in our system. Our system automatically extracts candidate viewpoints based on modeler's editing history. These views can refresh modeler's memory on the modeling process. The user can navigate to any of these views or right-click to save them. When a viewpoint is saved, it is displayed as an arrow in the authoring panel and as a thumbnail in the navigation panel. The user can also save viewpoints from different versions of the 3D model. The associated arrow and thumbnail are colored according to the color code of the version. Our system also provides a unique comparison view function. Users can toggle the side-by-side panel for comparing two versions. The authored viewpoint is visualized as a two-colored arrow. Users can also query candidate views by specifying regions of interest on the surface of the model. Here, a view surface that can be used to showcase the selected region of the model is created. The user can modify the surface with the mouse. By holding the Control key, the modeler can enter the constrained view mode and examine the 3D model from the authored surfaces. Our system can also suggest multiple candidate view paths based on the specified region. The user can switch between candidates, examine the model, and pick a favorite one. Here is another view path authoring example. To help refresh the author's memory, our system can be used to display the editing history of the model. Users can filter their history by selecting a surface region of interest. The user can also navigate between these views with the arrow keys. Once viewpoint authoring is completed, we reuse MeshMixer as a 3D viewer to interact and navigate within the authored views. Selecting a comparison view will automatically display the two corresponding versions. Users can navigate between authored views and observe the model while traversing along the authored view paths and surfaces. Alternatively, our system can output the authored information in the form of a 2D collage or as a temporal progress collage. All view paths on the 2D collage are pre-rendered, allowing the users to scrub them to traverse the path. We conducted an initial qualitative user study and received positive feedback from participants. In summary, our results and experiences indicate that using editing history for view authoring is a fruitful area of research.